Okay, hi everyone. Super excited to be talking today. I'd like to start off by thanking to whoever brought these club mates, which are really tasty. We don't have those in France or in the UK. So today I'm going to talk about making your React Native app work offline. And it's something that is not ready by default, and you probably need to spend some time thinking about how you could implement and how far you want to go with that. So I'm going to hopefully give you some magic tricks to make that easier. So I'm Woody. I work at a company called Theodo. What we do is that we build digital products that fix the business problems that our clients face. It can be small clients, it can be bigger clients, startups, corporates. And we need to be able to provide them with solutions that can be implemented quickly. And offline apps are not that quick to implement at the moment. So let's go back in time. Let's start the talk by going back in time in the different eras of client expectation when building an app. So this was the can you get the page to appear faster era. So you had usually something like a PHP full stack application, and what you wanted to do is to make the browser request to the server as fast as possible. So you had the developer spend his time creating database indexes, caching stuff, compressing stuff so that the HTML gets quicker to the browser. So there was basically no need for front-end real work to satisfy the clients. Then there was the era of jQuery and stuff like that, where the client was pissed off because widgets that used to work don't work anymore. So you spent your time as a developer finding widgets. You spend your time fixing regressions because you had trouble fixing and testing your JS code. And then we have this era, which is way nicer for us because there's a real room for front-end development. You can write cool React Native and React components. You do some fancy state management, so there's real intelligence behind it. And you just expect that the app is always going to work the way it does on your computer, which is not the case. And the client could say something like, oh, it doesn't work on the subway, and you said it was going to work, so what's going on? So this is the problem that we're facing today. Some made-up stats just to explain why it's important to actually think about offline issues. I put up some stats of where you might use a mobile app. So could be your dentist waiting room, where you have a poor 3G connection. So you need to think about that because the connection is maybe not that good. Then you have your office toilet where you spend a little more time. You have great Wi-Fi usually there, so it's not a problem. You have an awful Tinder date at a restaurant where you have 4G. So then again, it's fine. You spend a lot of time doing that. But then there's a big one, the subway. And for instance, you don't know what's going to happen with that. The stats are totally made up. It doesn't even add up to 100. But it's basically what I do. So basically, knowing that, you need to take care of that. What are the steps? Because we want to build something that is progressive. And to me, an app must be able to handle failure. It's going to happen. Even if you do everything that I'm going to present to you, it will eventually fail. So you need to have a way to handle these cases. And then you want to aim at avoiding failure. So those are two different strategies. One is, to me, mandatory. The other is you go as far as you can. So must handle failure has been talked about by, for instance, the company 37 Signals. They created Ruby on Rails, and they coined the term defensive design. And the idea is that for each feature you want to implement, you want to handle 3 states. The expected state, which is probably what you spend your time working on. There's the loading state that is there when the data is not yet in the app. And there's the blank state. And the blank state can be you have no data. It can be you have no network. It can be there's been a problem with the server. And you need to really think about the UX and the UI of all these states and how to handle the development of features. And then there's should avoid failure, which is optional. You can go as far as you want depending on the budget and the time you want to spend on it. And the idea is you want to decrease the probability of the user facing a state where the app is not functioning in an optimal manner. So there's 2 different aims, which is why I wanted to start with that. Basically, we're going to go through 2 main sections. It's going to be reading, like getting data in your app, and there's going to be writing. And this is if you want to make it match the HTTP words. Reading is get, and writing is everything else, post, put, patch, delete, whatever. And you want, ideally, to have both being handled in an offline fashion and find solutions for that. Let's start with reading strategies. So reading strategies, as I said, we want to focus first on handling failure. And defensive design, for fetching strategies can be as simple as putting activity indicators when you have a screen in React Native. You just put a loader. You have then more evolved strategy. The Facebook strategy here is to show content that looks like the final layout so that when the data gets here, it's not going to phase out the user. He's going to feel like the content hasn't really moved. And for long requests, you're going to want to have something that shows progress or at least like distracts the user. Postman has a nice little loader which puts some random sentences, something that can be quite fun. You can put jokes or Easter eggs there. The idea is to make the user wait and know that something is happening. So this is the basic loading state management that you want in your app. The blank state now, you also have some problematics. You want to fill the space. You don't want to have an empty app. So, for instance, Foursquare tells you in a very nice way that you don't have friends. And so the idea is you want to save the day, you want to provide a call to action to the user so that he can get out as quickly as possible from the blank state and go back to the normal state of the app. And then there's a second strategy which is used by, for instance, Google Chrome, which is hijacking. The guy you wanted to go to Stack Overflow, it doesn't work, but you can play with a dinosaur, and it's fine. So those are the two main strategies that you can do for handling blank state. So once you've done this defensive design, then you can move on to more fun stuff, which is to make it work offline and to basically reduce the probability of having these loading and blank states. What's amazing is that with Redux, you have already some sort of persistence in the store. So you get data from the server. Does this work? I guess, yeah. You get data from the server, and then it gets put in the Redux store. And just using Redux, you have foreground persistence, which means that when you move in the app, by default, the data is still there. And you also have persistence when the guy just hides the app and resumes it, which is already something interesting. And it's by default with Redux. If you want to look very quickly at the reducers, what you want to do is have you want to listen to request actions, to success actions and failure actions, pretty standard. And the idea is that if you want your data not to be erased when the guy returns to the screen, you don't want to actually erase, for instance, here we're fetching Trello boards, it's for an app I made, and you don't want to erase the boards when you have the request action being received. You just want to update the error and the fetching flags. And this is a very common pattern in Redux, and it's interesting because it also links to the defensive design I mentioned, which is you have an optimal state, which is looking at the boards. You have a blank state, which is in that case the error boolean, and you have the fetching state, fetching boolean, which matches the loading state. And by doing that, even if you re-request the data, the boards are not going to disappear from your screen, and it's not going to have an impact. The same for the failure, for instance, where you're not erasing the boards either, you're just updating the boolean error. Next up, if you want to go a bit further, you want to have something that is persisted when you kill the app. And the easiest way to do that, as some of you probably know it, is Redux Persist. The idea is that the Redux store that you have is going to be synced with usually the async storage on React Native. It can be local storage if you're doing a React app or any other storage that you want. And so the store is persisted, and once the app is restarted, the store is rehydrated from async storage. And by default, it does that with the whole store. Obviously, you can have some per reducer mechanism to rehydrate your store or do some different stuff with it. And then you may run into some issues. Classic issues when you want to persist stuff is size issues. For iOS, for instance, the limits of things you can store in the async storage is actually the space that you have on the iOS phone. But maybe you don't want your app to fill your phone with data. For Android, it's 6 megabytes by default, but you can change that. But you have to be aware that if you store a lot of things, it might lead into problems. You have some small libraries, I'm not going to go into detail with that help you to solve these issues. Redux Persist Transform Compress allows you to basically compress the strings that are in the store. You can win some pretty good improvement, and then you decompress it to show it on screen, for instance. And Redux Persist Transform Filter allows you to basically filter your state when you want to persist it. For instance, maybe you're only showing a title and you don't want to store a blob, image blob that you get when you do the request from the server. And by using that, you're going to not store everything in the server while being able to use the generic REST API that some other clients might want to have the blob of data or whatever. Next up, you want to be able to handle updates. I know that for some of you guys who've seen the talk before, talking about code push and stuff like that, you want to have as many updates as you want if you're agile, and this means that your store might change over time. For instance, in that simple case, you had just data held in your store, and you want to add the fetching flag, the fetching boolean in here. And this means that when you update the app, the store is actually, when it gets rehydrated, it's not going to hold the data that will allow your app to display the data. And so there's something pretty cool that's called Redux Persist migrate. The idea is you store some sort of a version in your store that allows you to execute migrations, just like if you were a backend developer, which is pretty cool. In that case, if I'm using currently version 1, and when I do an update, version 2 is available, it's going to modify my state to store in a different way the dating apps field and add in the fetching flag with a default value. And that way, the app, when it gets updated, is still going to be persisted. You won't have to do another request, even though it wouldn't be a big deal if you need to make a request when you update the app. It's just an example. So once you've done that, the idea is you want to warn the user that the data they see is not the freshest data available. And you want to warn the user of that. And you can see Facebook, what they're doing is that when you scroll up, it shows a little no internet connection, and it says also you can still post while offline, which is a bit of a spoiler of the writing part, because Facebook allows you to do write actions while being offline. An easy way to implement that is React Native provides the net info on its core library. And you can just listen to any connectivity change. And that way you have the Boolean is connected. You could dispatch a Redux action to just update something in your store and show this little UI element when the data is, the network can't be reached. So this is an easy solution to do that. So to finish up with the reading part of the talk, very simply, you may want to optimize further, which is what I was talking about when traveling back in time to make the requests get there faster. This is mostly back-end work. You have solutions for that, like Varnish, for instance, or Memcached. For those of you who don't know what it does, basically, if someone made the request 5 minutes ago, it's not going to do the whole database computations, querying that might be heavy and make the requests, the data gets slower in your app. It's just going to reuse the data because the server has stored it in the RAM. And you could implement very quickly some Varnish or something like that to improve the speed at which you get from the loading state to the optimal state. Let's move on to something that is probably more complex and less done in apps. I think that a lot of you have implemented in some way some caching for reading data. Writing, it's not that common. And again, we want to apply the same strategy. We want to start with handling failure. And for that, it's starting defensive. You can just warn the user that when he clicks on a button, it doesn't work. This is just a UI library that allows you to do it. It shows some little toaster that gets on the bottom. So this is when you haven't thought of writing strategies, you can just say the action didn't work because you don't have any network. And that way, your client, when he tries out the feature, won't be phased because he's seen that it's normal that it's not working, it's the network or whatever. Once you've done that, you can start taking risks. And the main strategy today for writing and offline apps is to be optimistic. And this is what Twitter is doing. This is what I've done in this small app that we're using for basically monitor Trello boards and get notification when developers do some stupid things. But basically, as you can see, I'm on plain mode, and I can just unsubscribe to board. The UI just says it's going fine. I don't need to know about the server not getting the data because I assume that the data is going to be sent to the server when my connection is restored, which is great because that way the responsiveness of the app is great and the guy can just do whatever he wants in the subway. When he gets out, the request will actually be sent to the backend, and so that's pretty nice. And so the idea, the concept behind that is you introduce, we saw before the three classic actions in Redux: request, success, failure. In that case, you have something called a commit action and a rollback action. And the idea is that commit, you're going to get that action when the server actually responded correctly to your request, once your connectivity is restored. And it's going to be a rollback when the server actually answered with a failure, which means that you then need to take that into account in your reducer to update. For instance, If I wanted to subscribe and it turned to unsubscribe when I had no network, but then when I got out, the server somehow failed, I need the unsubscribe to go back to subscribe because my action actually didn't work. So you need to be able to roll back when you've been too optimistic as to what should happen. So this is a simple implementation of how you could do that. The idea is to store in your Redux store some sort of a queue. So those are different steps in time. And let's say, for instance, that you do a first request. Let's call it black request. That's a Redux action. Then you have a blue request that you do right after. And because you have no connectivity, they're just going to stack in this queue that you hold in your store. And when connectivity is restored, the queue is going to be emptied once at a time, first in, first out. So, for instance, in that case, the black request failed. So maybe you want in your reducer to update the UI to reflect that there's been a failure. But it did get out of the queue because the request was sent to the server. And then the blue request actually succeeded. So in most cases, you won't want to do anything in your reducer when it succeeded because you've been optimistic. But maybe you actually need some extra data from the server to update further your UI. So you may want to also listen to this commit action type. So what's amazing is that something has been made to simplify these different strategies. It's called Redux Offline. This great guy did it. The idea is that it handles all your read issues that I mentioned before by wrapping Redux Persist and all its options, so you can just use it instead of Redux Persist. And it handles your write issues by implementing this optimistic strategy for managing your write actions with this queuing mechanism. So it just wraps all the net info stuff to implement this strategy. It's quite recent, so it's a bit unstable at the moment, but I found it quite easy to integrate. It's basically a Redux enhancer that you can add in your app, and it does the persistence by default. This is the basic configuration of it. In that case, you want to have an action that is optimistic to follow a user. So in that case, you see that the effect is what you actually want to happen when the connectivity is restored. By default, it's going to do a fetch request to this URL. This is a post request with somebody that you got in your action. And you then have two other fields, which I mentioned before, the commit field, which is going to trigger this action with some metadata if you want, and the rollback one that is going to also be sent when the request fails. And then in that case, you don't want to do anything for commit. You just want in rollback to remove what you've actually hoped it would happen when you were optimistic. So this is the very simple example of how you can do that to have optimistic updates and get everything back when you have the network. A couple of things you can customize actually once you want to implement Redux Offline. You can change how network requests are made. Maybe you have some sort of a middleware to handle your API. That can be done. It doesn't have to be using fetch by default. You can also update the strategy for detecting the network. Maybe you want to just hit google.com or whatever to check if the network is available because you don't want to use net info for some reason. You can also change the detection of I can't pronounce that word, errors. And the idea is that if the server answered with something that shouldn't be retried, it's that kind of error, and you want then to skip the retry strategy that Redux Offline does by default. When you have, for instance, a weak network and the server can't be reached, it's going to have some retry strategy that you can also modify. By default, it's going to retry, I think, in a couple of seconds, then the double of that, then the double up until 10 minutes, I think, until your request eventually gets to the server, which is quite practical. And you can customize all that to match your needs. It also works with React Web. It's using not NetInfo to detect the network, but it works in a similar fashion. So once you've used this great library, as in reading, you also want to warn your users that you're taking a risk and you're being optimistic about things. This is a simple implementation of that. As you can see, I'm on offline mode, I'm on plain mode. I'm unsubscribing and I want to maybe display some sort of error saying that the device is currently offline. This is what Facebook was doing actually. But I can still make changes because we trust that once my connection is restored, the changes are going to go to the server. This is like a very simple strategy that I implemented here. You want... Oh. Damn. I want to make the warning appear when I first make a request. Like when I click on subscribe, I want to make that happier. I want it to disappear on its own after a certain period of time, because I don't want it to be like blocking the whole screen, or if connection is restored, that way I just want to hide it. And finally, I want to prevent the next warning from appearing using some sort of a delay, to not have that a bit like I have on the GIF. You want to wait a bit before seeing it again, otherwise it's quite annoying for users. And so this is where side effects come in quite handy. For some of you who know Redux Saga, it's going to be easier. Those who don't might be a bit harder. The idea is Redux Saga basically allows you to handle side effects in your app. In that case, it can be well described with side effects. This is what I'm doing. I'm watching actions that require the network. In that case, I wanted to watch both subscribe and unsubscribe actions. So this is, with Redux Saga, I can just yield take, which will be, basically the idea is that I will go to this line only when one of these actions have been received. So if I get a subscribe, the code is going to go there. And if I get an unsubscribe, the code is also going to go there. And it's all in a while loop, so you know that it's going to be running in your whole app lifecycle. Then what I want to do, if I receive one of these actions, is to handle another generated function that is going to do this whole action dispatching side effects. And then I want to wait before going in the beginning of the while true, because I don't want this to appear all the time. So for instance, here, I'm just calling delay with fixed 1000, and this is not going to go back there until 6 seconds. So this allows me not to have this show up at every time. Now, what do I do what do I want to do when I receive one of these actions? I want to first get in my state the online booleans that Redux Offline gave me for free. It's always in my store. Once I have the online status, if I'm actually offline, I want to just send an action that would be captured in the reducer to update this UI. For instance, let's say that show connection alert is going to change something in my state that allows me to show this toaster. And then I want to do some fancy race condition. It's what I said before. I want to either go to the next line if 4 seconds have been spent, or if my connection has been restored. And I can do that by listening to Redux Offline action status changed if the payload is saying that the app is now online. So again, I'll give you my slides if you want to check it out. But basically, once the race condition is finished, I can just hide the connection alert. So I'm describing in Sagas basically what I've described before. Then in your UI, you can simply have a screen. I'm using the drop-down alert I presented before. If I used not to have the connection alert show, and now I want it to show, I'm going to just show the drop-down using the library I presented, offline device, for instance. And if, on the opposite, I'm switching from a state where I did want to show the alert to a state where I want to hide it, I just dismiss the drop-down. So this is how I can very simply put that on the bottom of my views, and it's going to work. And I've not updated that. It's supposed to be a view. Sorry. I'm planning to provide these small Sagas generators. So in React Redux Saga Offline to provide more help to more sugar syntax and handling side effects above Redux Offline. So follow me on Twitter, and hopefully it will be out quite soon. And so the last step that you want to take care about is, if you're being optimistic, there might be conflicts. And so this is something that is not handled currently by Redux Offline. Let's, for instance, state that two guys are making write requests on a shared resource, and they're both in the subway. And the result is supposed to be contradictory. So there's a conflict there. It's a bit like you're doing some weird Git stuff with another developer. You want to handle this. And in that case, you're going to need to do some things in the backend, because this is conflict resolution in the backend. You're going to need one of these guys. So this is mostly for put and patch requests. And what can you do when you want to handle conflicts? So this is a very simple use case where you have this, for instance, this first object is being fetched by 3 different people in time. This is time, okay? And then these 3 guys want to make an update at certain points in time, but they're offline. And those are the times where the actual requests land on the server, because guy number 1 just got out of the subway, guy number 3, guy number 2. And so you have lots of different strategies as how you can handle this. The default strategy, of course, is that guy number 2 is going to win, because this is the latest request that gets on the server. So if you do nothing, this is what should happen. But then you might want to say that guy number 2 should not win, because he made an update on something that is outdated, because guy number 1 got there first. He made the change. So another strategy might be to say the guy who wins is actually the first one in the line, because he's the one who made a request of change on some fresh data. And all these guys requested change on something that is outdated and is not that anymore in the server. The last strategy that you could have is very simply to say that the first guy who made the request while he was being offline should win. And in that case, it should be guy number 3 who wins. So if you want to, there are some use cases where it might make sense for you to actually handle these other strategies. But the only strategy that doesn't require you to trust timestamps sent by the client device is obviously the default strategy, where you don't have any knowledge of when data was fetched by the client, because this is a timestamp that you would put once the data is fetched, or when the request was actually attempted when he was offline. If you, however, want to trust the client, because it doesn't matter in that use case, you can just store, this is created at, and updated at, which are quite classical in databases, but you can also store a column holding the update attempted at, which matches these timestamps. And in that case, you're going to be able to handle other strategies. I provided a few of these helpers because I had this problem. I don't know if one of you guys knows Feathers.js, which is a cool Node framework. But I provided a couple of these strategies, and the idea is that you want to reject with a HTTP 409 error if there's been a conflict, which is the standard verb for it. If the update is rejected, this is quite simple. This is a hook that would be on your Feathers code. What you want to do is basically grab from the payload the update attempted at timestamp that is provided by the client, because you trust the client. And if for some reason the timestamp that you got from the client is actually after the timestamp that is stored on the server, currently stored on the server, then you want to reject with there was an earlier modified attempt, which means that